A suppressor, sound moderator, or silencer is an accessory device that is attached to or part of the muzzle of a firearm or air gun's barrel and reduces the noise signature, muzzle report, and visible flash generated by the gun's firing. Suppressors are typically constructed of a metal cylinder with internal baffle components to slow and cool down the escaping propellant gas and thus decrease the sound intensity of the muzzle blast. A flash suppressor, on the other hand, specifically cools or disperses burning gases typically exiting from the muzzle of a carbine-length weapon, without reference to sound reduction. In most countries, suppressors are regulated by firearm legislation to varying degrees. While some jurisdictions allow, and even mandate, sporting use of suppressors, especially to mitigate the costs of hearing loss and noise pollution, other governments ban them from civilian use. History. American inventor Hiram Percy Maxim, the son of Maxim gun inventor Hiram Stevens Maxim, is usually credited with inventing and selling the first commercially successful models circa 1902, receiving a patent for his silencer on March 30, 1909. Maxim gave his device the trademarked name Maxim Silencer, and they were regularly advertised in sporting goods magazines. The muffler for internal combustion engines was developed in parallel with the firearm suppressor by Maxim in the early 20th century, using many of the same techniques to provide quieter running engines, and in many English-speaking countries automobile mufflers are called silencers. Former President of the United States Theodore Roosevelt was known to purchase and use Maxim silencers. Suppressors were regularly used by agents of the United States Office of Strategic Services, who favored the newly designed high-standard HDM.22 long rifle pistol during World War II. OSS Director William Joseph Wild Bill Donovan demonstrated the pistol for President Franklin D. Roosevelt at the White House. According to OSS Research Chief Stanley Lovell, Donovan, an old and trusted friend of the president, was waved into the Oval Office, where Roosevelt was dictating a letter. While Roosevelt finished his message, Donovan turned his back and fired 10 shots into a sandbag he had brought with him, announced what he had done and handed the smoking gun to the astonished president. The British Special Operations Executive, well-rod pistol with an integral suppressor was also used by the American OSS on clandestine operations in Nazi-occupied Europe during the Second World War. Terminology. The U.S. National Firearms Act, NFA, of 1934 defines silencers and established regulations limiting their sale and ownership. Both the U.S. Department of Justice and the Bureau of Alcohol, Tobacco, Firearms, and Explosives, ATF, refer to suppressors as silencers. Hiram Percy Maxim, the original inventor of the device, marketed them as Maxim silencers. The earliest use of the term suppressor to refer to firearm noise reduction is in U.S. Patent 453-0417, July 23, 1985, a suppressor for reducing the muzzle blast of firearms or the like. In UK English, silencer is the common term for either a motor vehicle muffler and for a gun silencer. The Oxford, American Heritage, and other dictionaries apply the term suppressor to such contexts as electromagnetic shielding devices, genetics, and censorship, but not firearms. These dictionaries define both silencer and suppressor as essentially equivalent and interchangeable, neither applying exclusively or primarily to sound, and both being applicable as much to complete and total quiet or to partial reduction of sound. In 2011, the U.S. National Rifle Association began a campaign to increase the civilian use of suppressors for hunting and sport shooting, setting the goals of easing the restrictions in the federal NFA of 1934, and in various state laws, regulating the sale and ownership of firearm suppressors. In the same year, the American Silencer Association, ASA, was founded by U.S. manufacturers of suppressors, with the same goals of moving suppressors into the mainstream. Along with state and federal legislative lobbying efforts, the NRA and ASA began public information campaigns designed to change the perception of suppressors from their association with espionage, assassination, crime, or military special operation use, to instead show that suppressors have health and safety benefits, primarily protecting the hearing of shooters and people in the vicinity, and to debunk the perceived myth in popular television, film, and video game media that suppressors are so effective that gunshot sounds can go totally unnoticed, such as by people in the next room of a building. In 2014, the ASA changed its name to American Suppressor Association in a continuing effort to dispel myths about suppressors. Gun control advocates have said that changing the name from silencer to suppressor is semantic propaganda similar to the efforts to avoid terms like assault rifle or assault weapon in favor of friendlier-sounding language like modern sporting rifle, while gun rights advocates make essentially the opposite argument, and also that the widespread term silencer reflects technical ignorance and is poorly defined. Firearm noise anatomy. When a firearm is discharged, there are three ways sound is produced. Part of it can be managed, however, some of it is beyond the ability of the operator or manufacturers to eliminate. In order of importance, the three ways a firearm generates sound are: muzzle blast, shockwave generated by high temperature, high-pressure gases escaping and expanding from the muzzle after the bullet exits the barrel. Sonic boom, bullwhip cracking sound associated with high-frequency shockwaves created by an object exceeding the speed of sound flying through the air. Mechanical noise, sound generated by internal moving parts of the firearm action. A suppressor can only affect the noise generated by the two primary sources, muzzle blast and sonic boom, and in most cases only the former. While subsonic ammunitions can negate the sonic boom, mechanical noise can be mitigated but is nearly impossible to eliminate. For these reasons, it is difficult to completely silence any firearm, or achieve an acceptable level of noise suppression in revolvers that function under standard operating principles due to the looser gas seal between the barrel and the cylinder. Some revolvers have technical features that enable suppression and include the Russian Nagant M1895 and OTS-38 revolvers, and the SNW QSPR. Muzzle blast generated by firearm discharge is directly proportional to the amount of propellant to be combusted within the cartridge. Therefore, the greater the case capacity, e.g. a Magnum cartridge, the louder the muzzle blast and consequently a more efficient or larger suppressor system is required. A gunshot, the combination of the sonic boom, the vacuum release, and hot gases, will almost always be louder than the sound of the action cycling of an auto-loading firearm. Alan C. Paulson, a renowned firearms specialist, claimed to have encountered an integrally suppressed .22 LR that had such a quiet report, although this is somewhat uncommon. Properly evaluating the sound generated by a firearm can only be done using a decibel meter in conjunction with a frequency spectrum analyzer during live tests. Design and construction. The suppressor is typically a hollow metal tube manufactured from steel, aluminum, or titanium and contains expansion chambers. This device, typically cylindrical in shape, attaches to the muzzle of a pistol, submachine gun, or rifle. Some can-type suppressors, so-called as they often resemble a beverage can, may be detached by the user and attached to a different firearm. Another type is the integral suppressor, which typically consists of an expansion chamber or chambers surrounding the barrel. The barrel has openings or ports which bleed off gases into the chambers. This type of suppressor is part of the firearm, thus the term integral, and maintenance of the suppressor requires that the firearm be at least partially disassembled. Both types of suppressors reduce noise by allowing the rapidly expanding gases from the firing of the cartridge to be decelerated and cooled through a series of hollow chambers. The trapped gas exits the suppressor over a longer period of time and at a greatly reduced velocity, producing less noise signature. The chambers are divided by either baffles or wipes. There are typically at least 4 and up to perhaps 15 chambers in a suppressor, depending on the intended use and design details. Often, a single, larger expansion chamber is located at the muzzle end of a can-type suppressor, which allows the propellant gas to expand considerably and slow down before it encounters the baffles or wipes. This larger chamber may be reflexed toward the rear of the barrel to minimize the overall length of the combined firearm and suppressor, especially with longer weapons such as rifles. Suppressors vary greatly in size and efficiency. One disposable type developed in the 1980s by the U.S. Navy for 9x19 mm pistols was 150 mm, 5.9 in, long and 45 mm, 1.8 in outside diameter, and was designed for 6 shots with standard ammunition or up to 30 shots with subsonic, slower than the speed of sound, ammunition. In contrast, one suppressor designed for rifles firing the powerful .50 caliber, BMG, cartridge is 509 mm, 20.0 in, long and 76 mm, 3.0 in diameter. Apart from integral suppressors which are integrated as a part of the firearm's barrel, most suppressors have a female threaded end, which attaches to male threads cut into the exterior of the barrel. These types of suppressors are mostly used on handguns and rifles chambered in .22 LR. More powerful rifles may use this type of attachment, but harsh recoil may cause the suppressor to over-tighten to the barrel and the suppressor can become difficult to remove. Silencerco's salvo suppressor for shotguns attaches via internal barrel threading normally used to mount removable chokes. Military rifles such as the M16 or M14 often utilize quick detach suppressors which use coarser than normal threads and are installed over an existing muzzle device such as a flash suppressor and may include a secondary locking mechanism to allow the shooter to quickly and safely add or remove a sound suppressor based on individual needs. Advanced types. 2 ancillary advantages to the suppressor are recoil reduction and flash suppression. Muzzle flash is reduced by both being contained in the suppressor and through the arresting of unburned powder that would normally burn in the air, adding to the flash. Recoil reduction results from the slowing of propellant gases, which can contribute 30–50% of recoil velocity. However, some suppressors can increase the back pressure produced by the propellant gases. This can cause them to function somewhat like a muzzle booster and thus increase the felt recoil. The weight of suppressor and the location of that additional weight at the muzzle reduce recoil through basic mass as well as muzzle flip due to the location of this mass. Components. Baffles and spacers. Baffles are usually circular metal dividers which separate the expansion chambers. Each baffle has a hole in its center to permit the passage of the bullet through the suppressor and toward the target. The hole is typically at least 1 mm larger than the bullet caliber to minimize the risk of the bullet hitting the baffle in what is known as a baffle strike. Baffles are typically made of stainless steel, aluminum, titanium, or alloys such as Inconel, and are either machined out of solid metal or stamped out of sheet metal. A few suppressors for low-powered cartridges such as the .22 long rifle have successfully used plastic baffles, certain models by VAME and others 186-187. There are several unique baffle designs. M, K, Z, monolithic core, and Omega are the most prevalent. M-type is the crudest and comprises an inverted cone. K forms slanted obstructions diverging from the sidewalls, creating turbulence across the bore line. Z is expensive to machine and includes pockets of dead airspace along the sidewalls which trap expanded gases and hold them, thereby lengthening the time that the gases cool before exiting. Omega forms a series of spaced cones drawing gas away from the bore line, incorporates a scalloped mouth creating cross-bore turbulence, which is in turn directed to a mouse hole opening between the baffle stack and sidewall. Propellant gas heats and erodes the baffles, causing wear, which is worsened by high rates of fire. Aluminum baffles are seldom used with fully automatic weapons, because service life is unacceptably short. Some modern suppressors using steel or high-temperature alloy baffles can endure extended periods of fully automatic fire without damage. The highest quality rifle suppressors available today have a claimed service life of greater than 30,000 rounds. 363-364 baffles have not been given any specific angles, a specific size, or weight to meet any standards. They are created on a trial and error basis. Spacers separate baffles and keep them aligned at a specified distance from each other inside the suppressor. Many baffles and spacers are manufactured as a single assembly, and several suppressor designs have all the baffles attached together with spacers as a one-piece helical baffle stack. Modern baffles are usually carefully shaped to divert the propellant gases effectively into the chambers. This shaping can be a slanted flat surface, canted at an angle to the bore, or a conical or otherwise curved surface. One popular technique is to have alternating angled surfaces through the stack of baffles. Wipes and packing material. Wipes are inner dividers intended to touch the bullet as it passes through the suppressor, and are typically made of rubber, plastic, or foam. Each wipe may either have a hole drilled in it before use, a pattern stamped into its surface at the point where the bullet will strike it, or it may simply be punched through by the bullet. Wipes typically last for a small number of firings, perhaps no more than 5, before their performance is significantly degraded. While many suppressors used wipes in the Vietnam War era, most modern suppressors do not use them, as anything that touches the projectile has significant accuracy implications. All wipes deteriorate quickly and require disassembly and spare parts replacement. Wet suppressors or wet cans use a small quantity of water, oil, grease, or gel in the expansion chambers to cool the propellant gases and reduce their volume. See ideal gas law. The coolant lasts only a few shots before it must be replenished, but can greatly increase the effectiveness of the suppressor. Water is most effective, due to its high heat of vaporization, but it can run or evaporate out of the suppressor. Grease, while messy and less effective than water, can be left in the suppressor indefinitely without losing effectiveness. Oil is the least effective and least preferable, as it runs while being as messy as grease, and leaves behind a fine mist of aerosolized oil after each shot. Water-based gels, such as wire-pulling lubricant gel, are a good compromise. They offer the efficacy of water with less mess, as they do not run or drip. However, they take longer to apply, as they must be cleared from the bore of the suppressor to ensure a clear path for the bullet. Grease requires this step as well. Generally, only pistol suppressors are shot wet, as rifle suppressors handle such high pressure and heat that the liquid is gone within 1-3 shots. Many manufacturers will not warranty their rifle suppressors for wet fire, as some feel this may even result in a dangerous overpressurization of the silencer. Packing materials such as metal mesh, steel wool, or metal washers may be used to fill the chambers and further dissipate and cool the gases. These are somewhat more effective than empty chambers, but less effective than wet designs. 130 metal mesh, if properly used, may last for hundreds or thousands of shots of spaced semi-automatic fire. However, steel wool usually degrades within 10 shots, with stainless wool lasting longer than regular steel wool. Like wipes, packing materials are rarely found in modern suppressors. Wipes, packing materials and purpose-designed wet cans have been generally abandoned in 21st century suppressor design because they decrease overall accuracy and require excessive cleaning and maintenance. The instructions from several manufacturers state that their suppressors need not be cleaned at all. Furthermore, legal changes in the United States during the 1980s and 1990s made it much more difficult for end users to legally replace internal silencer parts, and the newer designs reflect this reality. Attachment. In addition to containing and slowly releasing the gas pressure associated with muzzle blast or reducing pressure through the use of coolant mediums, advanced suppressor designs attempt to modify the properties of the sound waves generated by the muzzle blast. In these designs, effects known as frequency shifting and phase cancellation, or destructive interference, are used in an attempt to make the suppressor quieter. These effects are achieved by separating the flow of gases and causing them to collide with each other, or by venting them through precision-made holes. The intended effect of frequency shifting is to shift audible sound waves frequencies into ultrasound, above 20 kHz, beyond the range of human hearing. The Russian An-94 assault rifle features a muzzle attachment that claims apparent noise reduction by venting some gases through a dog whistle type channel. Phase cancellation occurs when similar sound waves encounter each other 180 degrees out of phase, cancelling the amplitude of the wave and eliminating the pressure variations perceived as sound. Using either property to advantage requires that the suppressor be designed within the specification of the muzzle blast in mind. For example, the velocity of the sound waves is a major factor. This figure can change significantly between different cartridges and barrel lengths. However, these concepts are controversial because muzzle blast creates broadband noise rather than pure tones, and phase cancellation in particular is therefore extremely difficult, if not impossible, to achieve. Some suppressor manufacturers claim to use phase cancellation in their designs. From the practical perspective, supersonic cartridge loads are impractical to suppress past the levels that are merely hearing safe for the shooter due to the sonic boom emitted by the bullet, and cartridges such as .22 LR and .45 ACP have long been recognized as the easiest to suppress even if using technology dating back to the 1940s. Improvised silencers. Improvised silencers have been made from a variety of materials. In 2015, Los Angeles County Sheriff deputies recovered a ZBVZ 26 light machine gun with an automobile oil filter attached. PVC pipes, plastic water bottles, and foam-filled pillows are also used. In the United States, improvised silencers are governed by the same laws as manufactured ones. Characteristics. Functionally, a suppressor is meant to diminish the report of a discharged round, or make its sound unrecognizable. Other sounds emanating from the weapon remain unchanged. Even subsonic bullets make distinct sounds by their passage through the air and striking targets, and supersonic bullets produce a small sonic boom, resulting in a ballistic crack. Semi-automatic and fully automatic firearms also make distinct noises as their actions cycle, ejecting the fired cartridge case and loading a new round. Aside from reductions in volume, suppressors tend to alter the sound to something that is not identifiable as a gunshot. This reduces or eliminates attention drawn to the shooter. A Finnish expression dating from the Winter War says that a silencer does not make a soldier silent, but it does make him invisible. Suppressors are particularly useful in enclosed spaces where the sound, flash and pressure effects of a weapon being fired are amplified. Such effects may disorient the shooter, affecting situational awareness, concentration, and accuracy, and can permanently damage hearing very quickly. As the suppressed sound of firing is overshadowed by ballistic crack, observers can be deceived as to the location of the shooter, often from 90 to 180 degrees from his actual location. However, counter-sniper tactics can include gunfire locators, such as the U.S. Boomerang system, where sensitive microphones are coupled to computers running algorithms, and use the ballistic crack to detect and localize the origin of the shot. There are many advantages in using a suppressor that are not related to the sound. Hunters using centerfire rifles find suppressors bring various important benefits that outweigh the extra weight and resulting change in the firearm's center of gravity. The most important advantage of a suppressor is the hearing protection for the shooter as well as their companions. Many hunters have suffered permanent hearing damage due to someone else firing a high-caliber gun too closely without warning. By reducing noise, recoil, and muzzle blast, it also enables the firer to follow through calmly on their first shot and fire a further carefully aimed shot without delay if necessary. Wildlife of all kinds are often confused as to the direction of the source of a well-suppressed shot. In the field, however, the comparatively large size of a centerfire rifle suppressor can cause unwanted noise if it bumps or rubs against vegetation or rocks, so many users cover them with neoprene sleeves. Suppressors reduce firing recoil significantly, primarily by diverting and trapping the propellant gas. The gas generally has much less mass than the projectile, but it exits the muzzle at multiples of the projectile velocity, so reducing the speed and quantity of the gas expelled can significantly reduce the total momentum of the matter, gas and projectile, leaving the barrel, the negation of which, because momentum is conserved, is transferred to the gun as recoil. Paulson et al., discussing low-velocity pistol calibers, suggest the recoil reduction is around 15%. 38-40 with high-velocity calibers, recoil reduction runs in the range of 20–30%. The added mass of the suppressor, normally 300 to 500 grams, also helps to manage the recoil. A suppressor also cools the hot gases coming out of the barrel enough that most of the lead-laced vapor that leaves the barrel condenses inside the suppressor, reducing the amount of lead that might be inhaled by the shooter and others around them. However, in auto-loading actions this might be offset by increased back pressure, which results in propellant gas blowing back into a shooter's face through the chamber during case ejection. Subsonic ammunition. In weapons firing supersonic ammunition, the bullet itself produces a loud and very sharp sound as it leaves the muzzle in excess of the speed of sound and gradually reducing speed as it travels down range. This is a small sonic boom, and is referred to in the firearm field as ballistic crack or sonic signature. Subsonic ammunition eliminates this sound, but at the cost of lower velocity, resulting in decreased range and much decreased muzzle energy, thus lessening effectiveness on the target. For example, if the muzzle velocity is reduced from 2,700 feet/s, 820 m/s, common for f.ex.308 Winchester, to a subsonic 950 feet/s, 290 m/s, the muzzle energy is reduced by a factor of 8. Military marksmen and police units may use this ammunition to maximize the effectiveness of their suppressed rifles. While the range may be decreased when using subsonic rounds, this may be acceptable for specialized situations, where the absolute minimum amount of noise is required. However, the numeric effectiveness of subsonic rounds is, again, misrepresented by media. Independent testing of commercially available firearm suppressors with commercially available subsonic rounds has found that .308 subsonic rounds decreased the volume at the muzzle 10 to 12 dB when compared to the same caliber of suppressed supersonic ammunition. When combined with suppressors, the subsonic .308 rounds metered between 121 and 137 dB. This ballistic crack depends on the speed of sound, which in turn depends mainly on air temperature. At sea level, an ambient temperature of 70 degrees Fahrenheit, 21 degrees Celsius, and under normal atmospheric conditions, the speed of sound is approximately 1,140 feet per second, 350 m/s. Bullets that travel near the speed of sound are considered transonic, which means that the airflow over the surface of the bullet, which at points travels faster than the bullet itself, can break the speed of sound. Pointed bullets which gradually displace air can get closer to the speed of sound than round-nosed bullets before becoming transonic. Special cartridges have been developed for use with a suppressor. These cartridges use very heavy bullets to make up for the energy lost by keeping the bullet subsonic. A good example of this is the .300 Whisper cartridge, which is formed from a necked-up .221 Remington Fireball cartridge case. The subsonic .300 Whisper fires up to a 250 grains, 16 grams, .30 caliber bullet at about 980 feet per second, 300 m/s, generating about 533 foot-pounds force, 723 J, of energy at the muzzle. While this is similar to the energy available from the .45 ACP pistol cartridge, the reduced diameter and streamlined shape of the heavy .30 caliber bullet provides far better external ballistic performance, improving range substantially. 9x19 mm Parabellum, a very popular caliber for suppressed shooting, can use almost any factory-loaded 147 grains, 9.5 grams, weight round to achieve subsonic performance. These 147 gr weight bullets typically have a velocity of 980 feet per second, 270-300 m/s, which is less than the common 1140 feet per second, 350 m/s, speed of sound. The Soviet/Russian armor-piercing 9x39 mm ammunition used in rifles such as the Asval has a high subsonic ballistic coefficient, high retained downrange energy, high sectional density, and moderate recoil. Without using subsonic ammunition, the muzzle velocity of a supersonic bullet can be lowered by other means, before it leaves the barrel. Some suppressor designs, referred to as integrals, do this by allowing gas to bleed off along the length of the barrel before the projectile exits. The MP5SD is the best example of this, with holes right after the chamber of the barrel used to reduce a regular 115 or 124 gr ammunition to subsonic velocities. Effectiveness. Live tests by independent reviewers of numerous commercially available suppressors find that even low-power, unsuppressed .22 LR handguns produce gunshots over 160 decibels. In testing, most of the suppressors reduced the volume to between 130 and 145 dB, with the quietest suppressors metering at 117 dB. The actual suppression of sound ranged from 14.3 to 43 dB, with most data points around the 30 dB mark. The Delisle carbine, a British World War II suppressed rifle used in small numbers by special forces, was recorded at 85.5 dB in official firing tests. Comparatively, ear protection commonly used while shooting provides 18 to 32 dB of sound reduction at the ear. Further, chainsaws, rock concerts, rocket engines, pneumatic drills, small firecrackers, and ambulance sirens are rated at 100 to 140 dB. While some consider the noise reduction of a suppressor significant enough to permit safe shooting without hearing protection, hearing safe, noise-induced hearing loss may occur at 85 time-weighted average decibels or above if exposed for a prolonged period, and suppressed gunshots regularly meter above 130 dB. However, the U.S. Occupational Safety and Health Administration uses 140 dB as the safety cutoff for impulsive noise, which has led most U.S. manufacturers to advertise sub-140 dB suppressors as hearing safe. Current OSHA standards would allow no more than sub-single-second exposure to impact noise over 130 dB per 24 hours. That would equate to a single .308 round fired through a very efficient suppressor. This result effectively requires all users of suppressors to wear additional ear protection. Decibel testing measures only the peak sound pressure noise, not duration or frequency. Limitations of dB testing become apparent in a comparison of sound between a .308 caliber rifle and a .300 Winchester Magnum rifle. The dB meter will show that both rifles produce the same decibel level of noise. Upon firing these rifles, however, it is clear that the .300 Winchester Magnum sounds much louder. What a dB meter does not show is that, although both rifles produce the same peak sound pressure level, SPL, the .300 Winchester Magnum holds its peak duration longer, meaning that the .300 Winchester Magnum sound remains at full value longer, while the .308 peaks and falls off more quickly. Decibel meters fail in this and other regards when being used as the principal means to determine suppressor capability. In a physical sense, dB meters essentially take a short time average, RMS intensity of a sonic signal or impulse, over a specified period of time, sampling rate, and do not take into account the rate of increase of the sound wave packet, first derivative of packet envelope, which would in practice provide a better sense of the human perception of sound. Alan C. Paulson, of Paladin Press, writes that suppressors are considered a great help, along with hearing protection, to preserve the hearing of the use.
Please subscribe and thanks for watching.